Hello students, today we will be learning about how to draw the velocity diagram of slider crank mechanism. Slider crank mechanism is widely used for converting the rotary motion of the crank to the reciprocating motion of the slider. Before moving ahead, I hope you have gone through the previous videos of Introduction to Velocity Analysis and how to draw the velocity diagram of four-link mechanism. In case those who have not gone through those videos, please go through the videos. The link is provided in the description. To draw the velocity diagram of slider crank mechanism, we have taken up a problem which is as follows. The dimensions of an engine mechanism are as follows. Crank OA is equal to 200 mm, connecting rod AB is equal to 600 mm, the distance of center of mass from crank end AD is equal to 200 mm. At the instant angle 120 degree, that is after rotation of 120 degree, the crank has an angular velocity of 50 radians per second clockwise and an angular acceleration of 800 radian per second square. Calculate the velocity of D and angular velocity of AB, and acceleration of D and angular acceleration of AB. In today's lecture, we will be only dealing with the velocity diagram. So we will find out the velocity of D and the angular velocity of AB. In next lecture, we will be dealing with the acceleration diagram. So first of all, we need to draw the configuration diagram as stated in the problem. To draw the configuration diagram, we will take up a scale. The scale we have taken here is for 50 mm is represented by 1 centimeter. So to start with drawing the configuration diagram, we draw a central line. On this central line, we take a point O at which the crank OA is hinged, and it will also be the center of rotation of crank OA. At point O, we draw a line at an angle of 120 degrees. Now, since the crank is 200 mm and according to the scale taken, the crank will be represented by 4 centimeters. So we will take up a length 4 centimeter on our compass and we will cut the length on this line. So we get the point A and OA as crank. Next, we need to draw the connecting rod AB. The point B will lie on this central line. So we take up a distance of 600 mm according to the scale selected on the compass, and we'll cut the distance on this central line to get B, as shown as follows. So we get the point B. At this point, the slider is placed. The slider will be moving between these guides. So then we will join B to A. This will be the connecting rod AB. Then we have the point D on AB such that AD is equal to 200 mm. The crank will be rotating at an angular velocity of omega, that is 50 radians per second in the clockwise direction. So this is the configuration diagram. The motion of the slider will be horizontal between these guides. So next we will draw the velocity diagram of this slider crank mechanism. So to draw the velocity diagram, we take up a point which will have the marking O and G, as O and G are the fixed point in the mechanism. So we are given the angular velocity of OA. So by the use of angular velocity, we can calculate the linear velocity of the link OA. or the velocity of A relative to O as follows. So VA or VOA, that is the envelope, that is the velocity of A relative to O, will be equal to omega r, that is omega of OA into distance or the length of the link OA. So 50 radian per second and 0.2 meter is the length of the link. So 10 meter per second will be the velocity of A relative to O. So this velocity, as we know, is perpendicular to the link OA. So we have to draw the velocity vector of the link OA that should be perpendicular to the link OA. So for this, we take up a set square, 90-degree set square, and we place one of the sides on the link OA. The scale which we have selected here is 1 meter per second, is represented by 1 centimeter. So we take up the set square, one of the sides is placed on the link OA and the other perpendicular side will give you the velocity vector. So we will draw the velocity vector of length 10 centimeter according to the scale we have taken. We will get the point A here. So this is the velocity vector of link OA, or the velocity of A relative to O. This vector OA is of 10 centimeter, but it will be representing 10 meter per second. Next, we have to draw the velocity of B relative to A, or the link AB. We know that the velocity of the link AB will be in the direction perpendicular to the link, but we don't know the magnitude of this velocity. So we'll just draw a line which is perpendicular to the link OA with the help of the set square. We'll take the set square and we'll place the set square on its link AB, and the other side of the set square should pass through the point A, and we have to draw the velocity vector through the point A. So we'll draw a line which will represent the velocity vector of link AB. Still we don't know the magnitude, so we'll proceed further. So point B is on the slider. Next, we can draw the velocity vector of the slider B, G. So the motion of the slider is always horizontal in this case. So the velocity of the slider will be parallel to the direction of motion of the slider. That will, in this case, it will be horizontal. So we have to draw a line parallel to this motion of the slider. That means we have to draw a horizontal line. So if you are using a roller scale, you can directly draw the line parallel to this central line through point G. If you are using the set square, then you have to use this method. Like, first of all, you draw one perpendicular to that central line like this, and again you use the set square and you again draw a line perpendicular to the previous perpendicular to get the horizontal line. In this way, you will get the point B by the intersection of the velocity vectors of AB and GB. You get the point B. Now, so AB will be the magnitude of the velocity of the link AB, and GB will be the magnitude of the velocity of the slider. To mark the sense of the vectors, we need to write the vector equation. So the vector equation will be as follows. Velocity of B relative to O, velocity of B relative to O will be equal to velocity of A relative to O plus B relative to A, or the velocity of B relative to G will be equal to velocity of B relative to A plus velocity of A relative to O. That means if we write in the vector form, then GB will be equal to OA plus AB. It means GB will be equal to OA plus AB. So the sense and direction of the vectors will be as follows. This will give you OA plus AB will give you GB. So this is how you draw the velocity diagram. Next, you have to obtain this point D in the velocity diagram. So to do that, we know that the velocity of any intermediate point can be determined by the ratio of the sides or the ratio of the lengths of the sides. So before drawing the point D, we have to calculate the velocity of AB, so that we can find the point D by using the velocity of AB and the ratio method. So velocity of AB can be found out by measuring the vector AB. By measuring the vector AB, we have found it to be 5.2 centimeter. So by converting with the proper scale, we get the velocity of B relative to A is 5.2 meter per second. Again, we find out the angular velocity of AB. It will be V upon R, that is velocity of B relative to A divided by the length of the link AB. So angular velocity we get it as 8.67 radian per second. Now to plot point D, the intermediate point D, we take the ratio such that AD upon AB will be equal to length AD upon length AB. This will be calculated as follows, and we'll get AD as 1.73 centimeter. So this 1.73 centimeter will mark on this velocity diagram, on this vector AB in the velocity diagram as follows. We'll take the length on the compass, and we'll mark the point D as follows. So this AD in the velocity diagram is 1.73 centimeter. So we have obtained the point D. Now we'll join G to D or O to D to get the velocity of point D. We'll measure this vector OD. The vector OD has been measured as 8.8 centimeter. So according to the scale, we get the velocity as 8.8 meter per second. We can also calculate the velocity of slider. It is vector GB is measured as 7.2 centimeter. So the velocity of slider, that is velocity of B relative to G, is 7.2 meter per second. So this is how you get the angular velocity of the link AB is 8.67 radian per second and the velocity of point D is 8.8 meter per second. And this is how you draw the velocity diagram for the slider crank mechanism.